It's important to understand that oxides are in fact insulators. All in-service conductors will have an oxide layer present. How much depends on the age of the conductor and how corrosive the environment has been. Over years of service, this oxidation layer, when combined with surface contamination, presents a high resistance surface. This means it acts as an insulator. If the oxidation and contamination is not removed before applying a portable earth head clamp, it can result in a high resistance connection, where the head clamp doesn't make an electrical contact with the conductor at all. This happens especially with older copper. It is vital that you clean the conductor before applying the head clamp. In this video, we are looking at the difference in contact resistance when the surface of a conductor is dirty versus when it has been cleaned. This has a direct influence on how well temporary earths do their job. Remember that high resistance, combined with high current, results in a lot of heating. Ultimately, the clamp could melt, shower you with molten metal, or worst of all, remove your earth connection. The earth is there to prevent electric shock. It won't if it comes off. For this testing, we used a micro-ohm meter, which measures the contact resistance from the head clamp to the conductor in an as-found state before cleaning and after the conductor has been cleaned. The ohm meter is set to 100 amps for all the tests. The first sample is a piece of aluminium conductor, which has seen about 40 years of service life in the Wellington area. The conductor looks to be in pretty good condition. Before cleaning, the result is 2045 microohms. After a very quick clean, the result is dramatically less, at 121.9 microohms. That's reduced to just 6% of the uncleaned value. Conductor 2. The next conductor sample is also a piece of aluminium conductor, but this example shows visible contamination on the surface. The first result before cleaning is 3,390 microohms, while after a clean with a wire brush, the result drops to 199 microohms. Again, a reduction to just 6% of the uncleaned value. Both of these results show what a big difference just 20 to 30 seconds of cleaning can make. Oxidation on copper conductor is a very real problem when trying to apply temporary earths. Conductor 3. In the next example, we are testing a piece of copper conductor that has a layer of visible contamination on the surface. Before any cleaning takes place, the ohm meter returns a result of 3,105 microohms. After an initial clean, the result is still far too high, at 1,703 microohms. After an extensive clean, taking several minutes, we managed to get the result down to 154 microohms. We've got an example of a very heavily oxidized piece of copper conductor, similar to what was found on the recently dismantled Mangahao Paikakariki lines. Our first test doesn't return a result. The ohm meter shows the message, "Current loop fail, restart testing," which means the conductor is too corroded to get a reading. If you applied temporary earths to a conductor in this state, they simply wouldn't work as a means of protecting you from hazardous voltages. After some cleaning, we finally get a result of 910 microohms. After extensive cleaning, we get a satisfactory result of 103.3 microohms. So, before you go out to work, make sure that you have a brush for cleaning copper conductor and a separate brush for cleaning aluminium conductor, so that you don't cross-contaminate the brushes. The results speak for themselves. Clean to bright and shiny. Oxides are insulators. You can't bond to oxides. You need to make good electrical connections.